Have you heard of Euclidean algorithm and its connection with YouTube algorithm? We will find out the connection that exists between them in this video. Firstly, it is very important we know the applications or practical uses of YouTube algorithm. YouTube algorithm has numerous applications, of which just a few examples will be discussed in this video. The first to be considered is recommendations and personalization. YouTube algorithm recommends videos based on users' viewing history, likes and dislikes. Next is content creation and optimization. The understudy of YouTube algorithm by creators help them to develop effective content strategies. Also, the search engine optimization (SEO) helps creators to optimize their video titles, descriptions, and tags to improve visibility and search results. Still note that algorithm influences the selection of thumbnails and titles that grab users' attention. Other applications of YouTube algorithm include advertising and marketing, research and analytics, education and learning, music and video discovery, social media monitoring for social media trends, sentiment analysis, and influencer identification. On the other hand, Euclidean algorithm serves as one of the origins or building blocks of YouTube algorithm in computer science and programming. This explains the relationship that exists between YouTube algorithm and Euclidean algorithm. The number theory and mathematics of Euclidean algorithm include modular arithmetic and the computation of the greatest common divisor (GCD). This will take us to the next phase of this video, where we will calculate the GCD of the following sets of numbers using Euclidean algorithm.
The concept of calculating the GCD of a pair of set of numbers like we have here is very easy. Let's say we are to calculate the GCD of 1045. The concept is you are to pick this bigger number, which is going to be 45, this way, equating it to the other smaller number, 10, multiplied by a particular integer plus another integer. The integer here indicates the number of times 10 goes into 45, while the other integer here represents the remainder. So this is basically the concept of calculating the GCD of any pair of numbers you may be given. This number indicates the number of times the number here goes into the bigger number, and then the R represents the remainder. And that's how we move down the line using this concept to find the GCD of the set of numbers. So let's solve the GCD of 10 and 45 here. This is 45 equal to then the smaller number 10. 10 into 45 obviously is going to be 4. So that will be 4. We have 5 left. So in as much as 5 is left there, that's the remainder. And then the concept is we are bringing this one into this place. It replaces the number here. And then the remainder will be brought down to this place. So that's how we move down till we get 0 down. And then here is 10 coming to this place is 10 equal to, then this number is coming at 5. So 5 into 10 is 2. So this is going to be times 2. The remainder is going to be 0. And then now that we've gotten 0, the right answer will be the number that is preceding, the remainder that precedes 0 there, which is going to be 5. So the GCD of 10 and 45 is actually 5. So that is the answer of the first question. The second question we have there is 1701 and 3768. So we're to calculate the second question here, the GCD of 1701 and 3768. So calculating this, the solution is pretty easy. So let's go for the solution here. And then don't forget the concept, we bring the bigger number here and then followed by the smaller number. This is going to be 3768 equal to the smaller one, 1701. Okay, and then multiply by the number of times we can have 1701 into 3768 is actually 2. So times 2, the remainder is going to be 366. And then we bring this down here. So we'll follow the concept down the line. So this is 1701 equal to, and this the remainder comes here, that is 366 multiplied by the number of times we have 366 in 1701, and that's going to be 4. That's times 4. The remainder is 237. And then we keep going that way. This coming here, and that's going to be 366. This is 366 equal to, and this 237 comes multiplied by the number of times we have 237 and 366 is 1. That's times 1. And then plus the remainder is going to be 129. And then we'll bring this one here. That's 237 equal to, and then the number of times we have, and this one is here, that's 129. The number of times we have 129, 237 is actually going to be 1, that's times 1, and then plus the remainder is going to be 108. And I will bring this one here, 129 equal to, bring the remainder here, 108. The number of times we have 108 and 129 is actually going to be 1, and then it's remaining 21. So we'll bring this one here, 108, which is equal to the remainder, we'll bring it there. The number of times we have 21 into 108, that's going to be 5. That's times 5 plus the remainder is going to be 3. And then we actually bring this one here, that's going to be 21 equal to, then we bring the remainder here, that's going to be 3. The number of times we have 3 into 21, that's going to be 7, and the remainder is going to be 0. Until we get to 0, that's where we get to stop. And then the number that precedes, or the remainder that precedes 0, is actually the GCD. So our GCD for this set of number here, our GCD is actually going to be 3. So that's the answer to a question like we have there. Let's take a look at another calculation of GCD. In this case, we have to calculate the GCD of 1, 2, 3, 4, 5 and 5, 4, 3, 1, 2. So how do we get the GCD of this? Okay, don't forget the bigger number first followed by the smaller number. So the bigger number here is 5, 4, that's 3, 1, 2 equal to 1, 2, 3, 4, 5. This is actually 54,312, and this is 12,345. The number of times we have this into this is actually going to be 4. That's times 4. The remainder is going to be 4941. And then we bring this one here. That is 1, 2, 3, 4, 5, and the remainder comes here. That is 4941. Multiply by the number of times we have this into the bigger number, that's going to be 2, and the remainder is going to be 2463. 2463. And then we'll bring this one here, 4941 equal to, then the remainder is being brought down to this place, 2463. Multiply by the number of times we have this into this, that's going to be 2, and then the remainder is going to be 15. That's going to be 15. And then we'll bring this one here. This is 2463 equal to, then the remainder is being brought here. The number of times we have 15 into 2463 is actually going to be 164, and then the remainder is going to be 3. And then we'll bring 15 down here equal to, and the remainder is being brought here. The number of times we have 3 into 15 is actually 5, and the remainder is 0. Until we get to 0, that's where we get to stop, and then we go back to the remainder preceding 0. That becomes the GCD of a set of numbers given. So the GCD of this is actually 3. So that's the answer to the question given above. That's how to solve the Euclidean algorithm using that to calculate the greatest common divisor. Thanks for watching. Kindly subscribe to my YouTube channel.